Aging legs do not weaken because time passes, but because the signals that once kept them alive with strength, balance, and responsiveness slowly grow quieter. From a scientific perspective, muscle tissue is remarkably obedient. It grows when it is challenged, it maintains itself when it is used, and it retreats only when it is ignored. After the age of 60, many people assume that weakness is inevitable, yet biology tells a different story. The loss of muscle strength, often labeled as old age, is largely the result of reduced stimulation. When movement decreases, muscle fibers shrink, nerve connections lose efficiency, and blood flow becomes less dynamic. This is not decay in the dramatic sense, it is adaptation to inactivity. Inside every muscle is a constant conversation between the nervous system and the tissue itself. Motor neurons send signals that tell muscles when to contract, how strongly to respond, and how quickly to relax. With regular movement, these pathways remain sharp and responsive. When activity declines, the brain begins to send fewer messages, and the muscle, receiving less instruction, slowly reduces its capacity. This process can happen quietly over years, often unnoticed until climbing stairs feels heavier or standing up requires effort. What matters most is that this process is reversible to a meaningful degree, even later in life. Scientific studies consistently show that older muscles still respond to training. They may respond more slowly, but they do respond. Muscle cells retain the ability to synthesize protein, rebuild fibers, and improve endurance when given the right stimulus. The idea that aging muscles are worn out is a misunderstanding. They are underused, not expired. Even gentle, low-impact exercises can send powerful signals to the body that strength is still required, that balance still matters, and that circulation must remain efficient. There is also a psychological layer to reduced stimulation. Fear of falling, fear of pain, or fear of overdoing it often leads people to move less. This protective instinct, while understandable, creates a feedback loop. Less movement leads to more weakness, which leads to more fear, which further reduces movement. Science and compassion meet here, reminding us that careful, intentional motion is not dangerous. Inactivity is often the greater risk. From an evolutionary perspective, the human body was designed for lifelong movement. Our muscles evolved not for athletic perfection, but for daily use. When that daily use fades, the body simply reallocates resources. Energy is conserved, muscle mass is reduced, and strength declines because the body believes it is no longer needed. Reintroducing movement sends a clear biological message that the legs still have a purpose, that standing, walking, and balancing are still essential tasks, and the body responds by rebuilding capacity, restoring confidence, and slowly reawakening systems that were never truly lost, only waiting to be asked again. Simple daily movements have a power that is often underestimated because they lack drama. Yet, from a biological standpoint, they are among the most effective ways to restore communication between the muscles and the brain. Every intentional movement sends electrical signals through nerves, reminding the nervous system that the body is still engaged with the world. Over time, inactivity weakens this dialogue, not because the brain forgets how to move, but because it is no longer prompted to refine and reinforce those pathways. When daily movements return, even in modest forms, the brain responds with renewed attention, strengthening neural connections that govern coordination, balance, and strength. The human nervous system is designed to adapt. Scientists call this adaptability neuroplasticity, and it does not vanish with age. When an older adult practices standing up from a chair slowly or lifting a leg with control, The brain recalibrates how it sends commands to the muscles. Timing improves, unnecessary tension decreases, and movements become smoother. This refinement reduces the risk of missteps and sudden weakness, which are often mistaken as signs of irreversible decline. In reality, they are signs of undertrained communication. Muscles depend on these signals to maintain their structure. Without regular neural input, muscle fibers shrink and lose efficiency. Simple movements reverse this process by restoring the rhythm of contraction and relaxation. Each repetition is a message that says this muscle is still needed. Over days and weeks, blood flow improves, oxygen delivery becomes more efficient, and metabolic waste is cleared more effectively. These changes are subtle but cumulative, leading to noticeable improvements in endurance and stability. There is also a profound emotional component to restoring muscle-brain communication. When movements feel more controlled, confidence naturally increases. The fear that often accompanies aging legs begins to loosen its grip. This emotional shift further enhances physical function because the brain becomes more willing to engage the body. Movement becomes less guarded and more fluid, reinforcing a positive cycle of trust between mind and muscle. From a scientific perspective, it is not the intensity of exercise that reestablishes this connection, but consistency and awareness. A slow, deliberate step can be more neurologically meaningful than a rushed one. When the brain is fully present in the movement, sensory feedback from joints, muscles, and skin sharpens. This feedback loop allows the nervous system to fine-tune posture and balance in real time. Simple daily movements also anchor the body to routine, which the brain finds deeply stabilizing. Repetition at regular intervals strengthens neural pathways, just as repeated use strengthens muscle fibers. Over time, these movements cease to feel like exercise and instead become a natural expression of capability. The body remembers how to move with purpose. The brain remembers how to guide it with clarity, and the quiet dialogue between the two grows stronger, supporting mobility, independence, and a sense of physical presence that many fear is lost with age, but is, in truth, patiently waiting to be reawakened. Improved circulation is one of the most fundamental requirements for leg strength and endurance, yet it is rarely felt until it begins to fade. Blood is not merely a transport system, it is a living river carrying oxygen, nutrients, hormones, and chemical signals that tell tissues how to function. In the legs, circulation works against gravity, which makes movement essential. When the muscles contract, they gently squeeze veins and help push blood back toward the heart. Without this regular assistance, blood flow slows, tissues receive less oxygen, and fatigue appears long before the muscles have truly been challenged. As people age, circulation does not automatically fail, but it becomes more dependent on activity. The heart remains capable, but the peripheral systems, especially in the legs, rely heavily on muscular engagement. When movement decreases, the vessels become less responsive, and the efficiency of oxygen exchange declines. This is why legs can feel heavy or cold, even in the absence of disease. The tissues are alive, but they are undernourished in a subtle, chronic way. Scientific research shows that even light, repeated movements dramatically enhance blood flow. Simple actions such as ankle flexion, heel raises, or slow walking stimulate the vascular system. These movements cause blood vessels to widen slightly, improving delivery to muscles and nerves. Over time, this repeated stimulation strengthens the vessel walls and improves their ability to respond to demand. Endurance increases not because the muscles suddenly become stronger, but because they are finally receiving what they need to function efficiently. Circulation also plays a critical role in waste removal. Muscles produce metabolic byproducts during use, and without proper blood flow, these substances accumulate, contributing to soreness and stiffness. Improved circulation clears these byproducts more effectively, reducing discomfort and accelerating recovery. This creates a body that feels more willing to move again, reinforcing a cycle of activity rather than avoidance. There is also a connection between circulation and nerve health. Nerves depend on a steady supply of oxygen and nutrients to maintain signal clarity. Poor blood flow can dull sensation, slow reflexes, and weaken coordination. By improving circulation, simple leg exercises indirectly sharpen neural responsiveness, making movements feel more reliable and controlled. This is particularly important for balance, where split-second feedback can prevent a fall. From a broader biological perspective, circulation influences inflammation and healing. Consistent movement reduces low-grade inflammation by regulating immune signals and improving tissue repair. The legs, which carry the burden of body weight and daily activity, benefit greatly from this effect. Improved blood flow allows small injuries and micro tears to heal efficiently, preventing the accumulation of weakness over time. Perhaps most importantly, better circulation restores trust in the body. When legs feel warm, responsive, and less fatigued, the mind interprets this as capability. Confidence grows not from willpower, but from physiological feedback. Each step becomes less of a negotiation and more of a natural act. In this way, circulation becomes more than a mechanical process. It becomes the foundation upon which strength, endurance, and independence quietly rebuild themselves, one gentle movement at a time. Balance is often spoken about as if it were a fragile trait that inevitably fades with age. Yet, from a scientific perspective, balance is a dynamic system that responds to training at every stage of life. It is not located in a single muscle or joint, but emerges from the collaboration between the brain, the inner ear, the eyes, the nerves, and the muscles of the legs and core. When this system is challenged gently and consistently, it adapts, refining its ability to predict movement and correct instability before it becomes a fall. As people grow older, balance issues rarely arise from one sudden failure. They develop slowly as movement becomes more cautious and repetitive. When the body avoids challenge, the stabilizing muscles receive fewer signals, and the neural circuits responsible for coordination lose precision. This creates a subtle delay between intention and response. The body does not fall because it is weak, but because it is slow to react. Balance training addresses this delay by encouraging faster, clearer communication between muscles and the nervous system. Simple balance exercises, such as standing on one leg while holding a stable surface, activate deep muscles that are rarely used during routine walking. These muscles play a crucial role in making micro-adjustments that keep the body upright. At the same time, the brain receives rich sensory feedback from the feet and joints, sharpening its awareness of body position in space. This sensory input strengthens neural pathways, making balance more automatic and less mentally demanding. Neuroscience shows that the brain thrives on tasks that require attention and adaptation. Balance training provides both. Each attempt to maintain stability engages the brain's predictive systems, which learn to anticipate shifts in weight and correct posture before instability becomes noticeable. Over time, these corrections become faster and more efficient. The result is not just better balance, but improved confidence in movement, which further enhances physical performance. Balance training also has a protective effect on joint health. When stabilizing muscles are strong and responsive, they reduce unnecessary strain on the knees, hips, and ankles. This distributes force more evenly and decreases the risk of sudden twists or awkward landings. The body moves as an integrated system rather than a collection of isolated parts, which is essential for safe, fluid motion. Emotionally, balance training challenges fear in a controlled environment. Each successful moment of stability sends a powerful message to the brain that the body can be trusted. This reduces anxiety related to movement, which itself can interfere with balance by causing stiffness and hesitation. As fear diminishes, movement becomes smoother, and the nervous system remains calm and responsive. Balance, then, is not a gift that disappears with time, but a skill that requires conversation between body and mind. By training balance, older adults are not merely preventing falls, they are reinforcing neural pathways that support awareness, adaptability, and resilience. The legs learn to respond quickly, the brain learns to guide efficiently, and the entire system regains a quiet confidence that transforms standing, walking, and turning into acts of assurance rather than caution. Gentle, consistent exercise has a unique power because it works with the body rather than against it, especially in later years when resilience depends more on rhythm than intensity. From a biological standpoint, the body values regular signals over dramatic ones. Muscles, tendons, and nerves adapt best when they are reminded often that they are still required. This is why small movements done daily can produce greater long-term strength than occasional bursts of effort followed by long periods of rest. Consistency creates trust at a cellular level. Each time the legs are moved through a safe range, muscle fibers receive signals to maintain their structure and efficiency. Over time, these fibers begin to respond with improved tone and endurance. This process is gradual, but it is reliable. The body learns that movement is no longer a rare event to be feared, but a normal part of daily life. As this understanding settles in, stiffness decreases and mobility improves without force or strain. Gentle exercise also respects the connective tissues that support the legs. Tendons and ligaments adapt more slowly than muscles, and sudden, intense activity can overwhelm them. Consistent, low-impact movement allows these tissues to strengthen steadily, improving joint stability and reducing discomfort. This biological patience is essential for older adults, as it protects against injury while quietly rebuilding capacity. There is a strong neurological dimension to consistency as well. The nervous system favors repetition. When movements are practiced regularly, neural pathways become more efficient, requiring less conscious effort. This efficiency translates into smoother motion and quicker reactions. Confidence grows not because the mind decides to be brave, but because the body proves again and again that it can move safely. Psychologically, gentle consistency lowers the barrier to participation. When exercise feels achievable, it becomes sustainable. This reduces the mental resistance that often accompanies physical decline. Each completed movement reinforces a sense of agency, reminding the individual that progress is still possible. Over time, this sense of control expands beyond exercise, influencing posture, walking patterns, and willingness to engage in daily activities. From a scientific and human perspective, independence is closely tied to movement confidence. The ability to stand, walk, and balance without fear shapes how people interact with their environment. Gentle, consistent exercise restores this independence by rebuilding strength in a way that feels supportive rather than demanding. It allows the legs to regain reliability, which in turn allows the mind to relax. Perhaps the most profound effect of gentle consistency is its impact on identity. Aging often carries the narrative of limitation, but regular movement quietly challenges this belief. Each day of activity becomes evidence that the body is still responsive, still adaptable, still capable of improvement. Strength returns not as a sudden transformation, but as a steady presence. Independence follows naturally, not as a goal to be chased, but as a condition that reemerges when the body is treated with patience, respect, and unwavering consistency.